on your review, you're going to have a problem very similar to this problem right here. I didn't put the whole context down, but you have a surveyor, and the surveyor has gotten these specific angles and measurements from one side of a river. So the first thing we want to do is approximate the distance from A to C. Now, anytime you have two angles, it's always law of sines. Law of sines is you always use when you have an angle and its corresponding side, which currently we don't have an angle with its corresponding side. We only have one side, but we don't have the angle across from that side. So that's the first thing we're going to find. We're going to find angle C by doing 180 degrees minus 55 minus 86. So I'm going to do that, and I get 39 degrees for my angle C. Now that I have that, I'm looking for side, you can call it side B, you could call this X. AC is this side right here. So I'm going to go ahead and do sine of 39 over 154, because that's the one that has the complete relationship, both the angle and side, equals sine of, and since I'm looking for side B, I'm going to put angle B, so 55 degrees. This is part A, by the way. So our little quick trick we've talked about, sine of 39 will be in the denominator because it's diagonal from the variable. And then we have 154 sine of 55. And then I just type that in. 155 times sine of, 154. I'm typing it in wrong. All right, divided by sine of 39. All right, so you should get about 200.45. And this would be feet for part A, which I don't think it requires you put that in. Okay, so now that we've done part A, part B is what really confuses people. The reason it confuses people is because you're finding the distance across the river. On the homework, it does give you a hint where it says it's the height. That's pretty important because when it comes to height, what's happening is you are taking a point from one side of the river and you're going across and you're forming a right triangle. Oops. So this is now a right triangle right here. So that's a right angle. I'm going to highlight what I'm talking about. Let's do it in the black highlighter. So this triangle right here is what I'm focused on. So that means this angle is still 86 degrees. That 86 degrees, it's kind of a little in a weird spot, is right here. We've got a right angle, which I'll highlight in red. This is our right angle right here. We now know side B. I'm going to label that as 200.45. And in fact, just to really drive in what I'm trying to get at, I'm going to go ahead and get rid of every piece we don't need now. So we don't know what that length is, so we're essentially using this brand new triangle right here. Now, you could go ahead and do law of sines on this triangle if you wanted. I actually don't because it's a right triangle, but law of sines would work. I know I've seen a lot of students just go, okay, well, sine of 90 over 200.45 equals sine of 86 over h, because that's what we're looking for. This is the side we're looking for, is that h. Well, I don't actually need to do that. That's fine. Because it's a right triangle, you can use SOHCAHTOA. So I'm using angle 86. This is my opposite side, the h's, and then this is my hypotenuse. So I can go ahead and say sine of 86 degrees is equal to h over 200.45, which means h is equal to 200.45 multiplied by sine of 86, and then you just type that in. So 200.45 times sine of 86 is about, I'm actually going to put it right here, h is about 199.96 feet. And that's your answer.